Hello guys, so in this video we are going to design the LLD for a jackpot machine. Let's first discuss about the jackpot machine in short. So in a jackpot machine we are having three slots here, and in each slots we can have multiple digits from 0 to 9, and there is something called lever or a kind of a equipment which you can pull, and once you start pulling it the numbers on the slots gets changed, and at the end they kind of get stopped at particular digit, and if all the digits in all the slots are same then you won the game, otherwise basically you lose the game or you can pay more to keep playing that game. So this is the overall idea about a jackpot machine. In this basically we are given three slots. Each slot can have a digits from 0 to 9. You get 10 chances. Basically you can pull the lever 10 times, and winner declaration is, there are two conditions for winner declaration. 4.1 is this: if all the digits on on all three slots are same, that is one of the winning criteria. And other thing is they have given this sequence that, hey, if in the first trial they get 449, in the second trial they get 994, and the third trial get 885, then basically this is also another way you can win the game. Basically they have given multiple winner declaration criteria. We can, now the feature is basically user should be able to start the game, and as I was mentioning, that user can pull the lever and they can trigger the game. Basically when I say trigger, basically all the digits will start getting changing on all the three slots, and at the after some time they will get stopped at particular one. We need to keep track of the outcomes, and at then we need to declare who is the winner and who is the things basically. So in, if we just discuss about this entire thing, what we have seen is basically there is an entity called slot here. A jackpot machine is overall a bigger entity. We have a slot, we have the digits, so we can say random number generation is also there, because each slot is getting stopped at a particular digit, so we can say one of the thing is random number generation. We have multiple slots, we have a player here, we have a lever here. So these are there's a player, yeah, so these are the basic entities which we are having, which we have mentioned here: player, score, slot, random number, and a jackpot machine, a bigger one basically. Okay, now the important thing which we need to discuss is, in future there can be more than three slots also in a machine. So we can say, hey, let's have four slots, let's have five slots, and all that thing. There can be also multiple player playing the game turn by turn, and the slot ranges can also change. Right now we are just having a 0 to 9. Tomorrow we can have 0 to 100, or we can have a some pick list of the numbers which we can use in this jackpot machine. Okay, so let's see the code here. Okay, so this is the basic code which we are having. So this code which you are seeing currently, it's like just in the free public blog, but here in the paid version you will see a code like this. Here if we see, we are having let me show you the basic entities first which we are having. So here, as we were discussing, we have the jackpot machine, we have the slot machine, we have the slot factory, we have the winner strategy, we have the game observer. Okay, so in this slot factory is just to, it's a factory pattern which we are using to generate the slots. Not like very much important in this use case. Okay, this is the winner strategy. Basically we are using strategy pattern here, where we can have multiple strategies for deciding the winners. Game observer is just for whenever is there any change on the game and we want to update the players or the board for that. And this is the slot machine which we are having, which contains the random generation part and other things basically. Let's first go with the slot generation. So in the slot generation, what we are having this class, and we are having a random number. So whenever we are going to call the spin, it is actually going to return this three random numbers from this slot machine basically. So this particular is actually representing all the slots, all the actual three slots. So that's why if you see here, we are having three numbers: 1, 2, and 3. Okay, so whenever you will call this spin, you will get the three random numbers which you are going to show on all the slots basically. So this is the slot factory, just a basic, and we can just move on. So this is here we have defined the winner strategy, and we are going to kind of expand it and use the strategy pattern here to define how we can find it out whether. So this is one of the criteria which we have seen in the code also, in the description also, that if the count, if all the values are same, and then basically that is also one of the major winning strategy. And the another strategy is defined here. Game observer is here, if you see game logger. So whenever there will be any update on the game, the game logger is going to log all those changes. It can be updated, it can be more about updating to the players also. We can register the player observers and all those things also here. Now let's go to the main jackpot machine. Here we are using this jackpot machine instance. Attempt left is the thing which we have discussed, that user can try to play this jackpot machine 10 times. Then we have the spin history. Here we are tracking the record of all the spin numbers, whatever we have got, that hey, in the first trial we got these numbers, in the second trial we have got these numbers. And then we have these slot machines. As I was saying, this is the observers which we are having. So it can be a player observer, it can be other kind of a observer. Whosoever want to know what is happening into the game, we can just register those observers here, and they can, whenever anything update happen to the game, we can just pass those updates to them. Okay, so we are using singleton pattern here. Basically we are making sure that we are only able to generate single instance of this jackpot machine. This is what I was saying, that you can add the observer here to so that if any changes happens on the game, it will be passed to all the observers which were added. Now pull the lever. Let's see here. What do we mean by pulling the lever? That means once you pull the lever, the spinning of the rotation of the digits on the slots will get started. As you can see, slot machine dot spin will get started, and at the end you will get the results. Here you are like updating the attempts and doing all these things, and then checking the win. Notify the observers is one of the things. So you are notifying about the results. Let's go to the notify here. So it will pass this result to all the observers whosoever wanted to know about the game updates. And then we are having this check win. So here we are using this strategy pattern. We are using the strategy pattern which we have already used. So we are defining that. And then we are checking whether this is the chances. This given record is the way we can see if the new slot machine numbers are open for, basically are they equivalent to the winning formulas or not, basically. So that is the thing. And then basically at the end we are checking after every attempt whether the game is over or not. So instead of actually using this is attempt left, you can actually check is game over also, something like that. Or oh, sorry, I think I messed up. So is game over, just to set that hey, we want to end the game here, and we can just call this function, or and it will set the attempt left to 0. So if we see this design looks very simple, but there are multiple issues here. So if tomorrow you want to have multiple slots, you are going to update this code, and this is actually breaking the solid principle, basically. So we wanted to make sure that you are open. I mean, classes needs to be designed in such a way that they are open for extension but closed for any change. And if you want to add a slot, you will have to actually make the change here, which is not a good design. So this is also one of the issues here. Another issue is basically this code is not going to work for the concurrency for multi-threading environments. Because this attempt slots, if multiple threads are kind of trying to use this slots at same point of time, it will not work. What if attempt left was kind of 1 and 2 threads were trying to kind of use this value there? So I mean, in the multi-threading environment, this definitely we are going to face the issues. Let's see if we have, okay, we have not mentioned here, but yeah, so these are the two issues which I can see in the design. One is definitely this slot machine. Another one is that entire code is not multi-threaded. So we definitely need to fix that part also. Let me see if we can see any other thing. So if we go to the design, important points in the design, it was that it can have more than 3 slots. Definitely we will not be able to do this. Other thing is we can have multiple players who are using the same machine. This will not work if we are having multi-threading environment. So actually no. So definitely we can do this. So we can have multiple players in the current format also. Let's see. So if we go here, So currently we have not done it, but what we can actually do is we can create something like this. Let me just do it. So I'm not sure why it's just going back to, wait, just give me a second. Okay, there is some issue there. Okay, so we can do something like this. Wait. Okay, just give me a second. So we can do something like this. Currently we are not having the players, but we can do something like this. We can have a class called player. Okay, we can have a list of players, and we can just store it something like this. So we can have multiple players for sure. Here I was facing the issue because of the port issues. I'll fix it later on. But yeah, we can introduce multiple players here. But this code will require to have some changes. For example, in this one, so definitely we will have to make some changes in pulling the lever. We need to pass the player and all the thing. That's a solution we will cover in our premium course. Other thing is slot ranges may change in future. So this is again a very big issue in this one. So here we have hard coded our number. We are using the random number, and that too. So it's like saying we are saying that the number which we are looking on the slot is from 1 to 10. That is fine. But as I mentioned, that ranges can change. That means we will have to change this. We will have to make it 12, 13, 14, 15, 16, something like that. That is going to create an issue because we are actually again breaking the principle. We are, first thing is we should not have used the hard coded number here. And there is, if we, even if we change it to like a dynamic number, still we are having the issue. What if tomorrow we say, hey, that the slot digits are something like this: 1, 2, 3, 5, 8, something like this. So it can be there. In that case, definitely this entire class will not work. We will have to move to the different one. So this is also one of the breaking point here. We will be covering these drawback of the design in our premium course. Let me see if we are missing anything more. I think we are fine for now.